afternoon, everyone. Thank you so much for joining us with Shark Energy presenting for Chicago Water Week. We have a number of attendees who will be joining us shortly. So we're just going to wait for them to join into the webinar here, and we'll get started in just a minute. Everyone, we're just going to give it a couple more, another minute or so, just to allow a few more attendees to join, and we'll get started shortly. Thank you. All right. Good afternoon, everyone. Thank you so much for joining. We may have a few more attendees coming in a little bit after the presentation starts, but thank you all so much for joining us. My name is Brock Trimble. I'm the Director of Technical Sales for Shark Energy. We are a company located up in the Pacific Northwest, just outside of Vancouver, BC, Canada. And we make equipment that is used to recover energy from wastewater. So I imagine that everyone saw that in the webinar description. Hopefully, it piqued your interest. As we go through, we're going to talk about a few little topics: wastewater energy, what it is, and how it's used, the equipment that we produce in order to access that energy and move it to and from building spaces, and then a couple of practical examples of these projects that are out in the world. So what we're going to do, there's a Q&A section in using the platform. You can please use that Q&A to put in your chat with any questions, comments, etc. We'll wait until the end of the webinar to look at those questions, comments, etc., address anything, and hopefully leave everyone feeling really well informed with what wastewater is. I'm sure it's a brand new concept for many of you, but suffice it to say, it is a powerful tool when looking at energy, energy recovery, electrification, really from small to large scale. So I'm going to turn off my camera just to save a little bit of bandwidth here and get the presentation started. So hopefully when everyone is able to see this, again, we are Shark Energy presenting for Chicago Water Week. And again, looking forward to answering any and all of your questions towards the end of the presentation. All right, so really quickly, I'm going to pose a question to the group here. What is the value of wastewater? And we have a quick poll that we're going to start. Um, our IT attendee is just going to pop that up for everyone here, and we'll give everyone about 30 seconds to take a look at that, and then we'll post the results. So as you're selecting your choices, just think about wastewater as an energy source, what its viability is in terms of moving energy to and from it, what it can do for your building, and on a large scale across the nation, how much energy is thrown away through wastewater each year in the U.S. So we'll give everyone here another 10 seconds or so, and let's see those results. So most people have guessed roughly 3.5 billion kilowatt hours of thermal energy. That is a pretty close number. So JL, would you mind just closing down the poll there? So in reality, the value of wastewater, the US Department of Energy estimates that over 350 billion kilowatt hours of energy are discarded through your drains on an annual basis in the US alone. So if you think about how much water you use throughout the day, every different type of fixture and application you might have, whether it be washing dishes, clothes, simply washing your hands, taking a shower, going out into the broader world, and using all of those same or similar applications, all of that energy that is used to heat up your hot water is almost immediately thrown away down the drain. And all of that is really valuable energy that we can use to capture, recover, and reuse. And for quick perspective, that's almost 88 Hoover dams worth of heat energy that's simply being thrown away down your drains. So, in terms of an average statistic, the average person in North America uses around 24 gallons of hot water per person per day at 140 degrees Fahrenheit. As I mentioned, all of those different types of applications within your home and out in the broader world all use that energy and are simply being thrown away. In multifamily residential projects, even single family homes, the average wastewater that leaves your site is around 70 degrees Fahrenheit. So all of those hot water applications mixed with some of your cold water applications like toilets, water closets, tempered water for washing your hands, etc. All of that leaves your building around 70 degrees Fahrenheit, and that's a fairly standard average across North America and throughout the seasons. So it's a very nice, stable, and relatively predictable temperature that we can then gain access to. When we're looking at commercial and industrial applications, stuff like hospitals, hotels, commercial laundry facilities, ice rinks, and pools, anything that uses and throws away a lot of hot water, uh, those temperatures can reach 140 degrees or even higher. If you think about items like commercial kitchens, really, really hot dishwashers, sanitizers, all of that hot water is thrown away. And it's a really, really valuable tool. Again, capturing that, recovering that, and reusing that energy. So when we look at wastewater sources, we often look at black and gray water from within individual buildings, as well as larger sanitary sources like sanitary sewers and even end of line areas like lift stations or treatment centers that are collecting wastewater from very, very large parcels of land in order to treat it and ultimately throw it away. Now, wastewater is an excellent source because it can be used not only for energy recovery, but also for energy rejection. So, in this, we're able to provide basically a source for heat sink and heat source when it comes to heating and cooling. So, if you look at this chart, you'll see wastewater is really in this nice range. It's a beautiful ambient temperature where cooling loads are able to reject energy into wastewater using it as a heat sink, or when you're looking at heating loads, you're able to take energy from that wastewater and send it into your building space to be used for heating source. So it really provides this excellent medium sort of energy availability to use for two different applications, heating and cooling, with this nice visual representation here. So we always get the question, why wastewater? Why is it that we chose to look at wastewater as this source of energy to draw from or to sink to? Well, for one thing, it's essentially a limitless source material. It's always flowing out of our buildings, beneath our feet, uh, throughout our sanitary sewers, and it's that really nice, consistent temperature throughout the year. If you think about all those items that I just discussed, all of your fixtures, you're typically going to use your shower at the same temperature every day throughout the year. You're going to wash your hands roughly the same temperature throughout the year. Because of that, we don't really see too much of a difference when it comes to seasonality or geographic location, and that lends wastewater to be an extremely, well utilized source of energy throughout the year. By using wastewater, we can also have a number of benefits. First of all, in reducing the energy losses from buildings. Uh, our buildings are becoming more and more sophisticated, trying to keep all of that space energy in or out, keep it really nice and conditioned at an optimal temperature. However, wastewater is still that last point within a building that everyone knows that energy is simply thrown away. So if we can limit that energy loss and recover it and put it back into those buildings, you can have a huge impact on your overall energy losses from within your buildings. We can also work to offset GHGs. So using this, recovering energy and using an electrified source of heat, we are able to offset natural gas or other fossil fuel burning appliances and reduce that GHG emission that would otherwise be seen by a fairly significant factor. Number of other additional benefits like energy use, operational costs, especially in areas where we have CO2 taxation, lots and lots of benefits. This type of system also really helps to define and drive forward the high efficiency electrification that the market is demanding. So, with this, we're seeing the requirement for low emissions, for high efficiency electrification. And with this, these tend to lead themselves towards heat pumps. And even further than heat pumps, leaning towards low GWP or low global warming potential refrigerants. So all of these things we are seeing in our market, as well as local legislation, are able to be supported through the use of wastewater energy recovery, wastewater energy transfer, and the equipment that we at Shark Energy provide. We're also seeing a number of incentive programs located throughout North America that are driving all of these things, especially when it comes to specialized equipment for exact purposes like ours. So, with that, let's look at a couple of the products. So we at Shark produce two pieces of equipment, the Piranha and the Shark. Now, these are two different pieces of equipment that I'll go through in just a few minutes, but you can see for relative size and scale, the Piranha is really designed for individual building applications. And by this, we mean small to medium multifamily residential, as well as small to medium commercial and industrial. When we look at larger applications, that's where we would start to look at our Shark system. These are really well designed for large multifamily residential, and that by that we mean either large single building or multi-phase buildouts, as well as medium to large scale commercial and industrial applications, and being able to scale all the way up to district heating and cooling networks. So we're going to look at the Piranha first. This unit here is what we produce, and the Piranha is a very specialized water-to-water heat pump. For those of you that are unfamiliar with heat pumps, I'll go through sort of how they operate in just a minute. But these units are able to take wastewater, raw untreated black water, directly into the units. We are able to recover the energy directly from a very specialized evaporator tank. We recover the energy from wastewater into a refrigerant circuit, use that refrigerant circuit to boost and amplify that available energy, and deliver hot water directly out into a building. So this Piranha is available in three sizes, or T5, T10, and T15, and they each have their nominal design heat output that you can see here, 60, 120, and 180 MBH. So that's MBH is 1,000 BTUs per hour. So 60,000, 120,000, and 180,000 BTUs per hour output. Now, these units, very much like any other boiler or heat pump that you might be familiar with, are able to be installed in parallel, multiple units running side by side, in order to increase the overall energy recovery and energy output capacity that we have for the system. So the Piranhas are designed for domestic hot water applications. With this, for complete potable applications, we have what is called an NSF 372 rated braze plate heat exchanger. This basically just means that the piece of equipment that interacts with the potable water itself is able to be rated for drinkability, human consumption, etc. That's really a key to making sure that, especially because we're working with wastewater, we keep everything absolutely safe. Several layers of separation between the wastewater source that we're drawing energy from and the potable water that we're putting energy into. Now, the hot water, typically designed for domestic hot water, can also go into space heating or any other type of application that you may have. Really, the goal is just to recover that energy that would otherwise be thrown away and use it for hot water within your building space. Now, I mentioned the term GWP, global warming potential. What the Piranha has is a specialized refrigerant called R513A, which sees less than half of the GWP of the industry standards. So, our goal with the Piranha is really just to make the most effective, most environmentally friendly piece of equipment and really lead the pack, providing you, your sources, your buildings with the best piece of equipment that we possibly can. And the last note here, the Piranha is completely sealed at the site of installation. So because we're working with wastewater, we want to make sure that all of that wastewater stays, where it needs to, and it doesn't escape into the environment. Completely sealed, sanitary, and odor-free for these Piranha units that you see here. Okay, now a little bit of a science lesson for everyone who's unfamiliar with heat pump technology. The Piranha, as I mentioned, it's a heat pump, and heat pumps have been around for 100 years. We've done very little to change what a heat pump is, other than to develop a way to draw energy from wastewater. Now, the problem with wastewater is that there are solids. Anything that you might flush down the toilet that might drain down a tub or through a kitchen sink, that type of thing, that will make its way into the wastewater. Those solids would typically have an effect on any other type of heat exchanger, clog it, and make sure that eventually they would degrade flow. They wouldn't be able to transfer energy effectively. So what we've done is to develop what we call our evaporator tank. And with this, we pump wastewater, all of that raw, black, untreated wastewater into that evaporator tank. We make sure that we're separating everything, keeping the wastewater on one side, and then we have the refrigerant on the other. The refrigerant absorbs the energy from that wastewater, runs it through a compressor, and outputs a much higher temperature in the refrigerant. And all of that really hot energy is then transferred into your water, your potable water, across the wall of that very specialized potable condenser, delivering hot water into your building on an ongoing basis. And then the really cool thing about this whole concept is that as hot water is being consumed within your building, it immediately flows back down your pipes into that holding tank or that wastewater collection point where that energy can then be recovered, run through this process again, and delivered into hot water. And that process just continues on and on and on throughout the day, essentially in perpetuity. And for everyone to see here, this is what we call a typical above grade Piranha installation. So this means that the Piranha is sitting above your sanitary piping or your sewer piping. We are able to pump wastewater and any of those solids up and into the Piranha, into that very specialized evaporator tank. We recover the energy, outputting hot water into your building, completing that cycle. And ultimately, we have down here what we call a drain valve. We open that up. It's just an automated ball valve, and we get rid of all of the used liquid and solids that we've moved using that pump directly downstream and out to the city sewer. So we're really only temporarily catching that wastewater in order to gain access to that energy before sending it on its way, as would be normal with any building application, down to your sewer, down to your treatment center, to be treated and discharged out to environment as it normally would. So hopefully all of that was pretty clear. We will take some time at the end for the Q&A. If you have any questions, please pose those through the chat function. We'll make sure that we address anything at the end. And with that, let's jump into the Shark series. So the Shark operates differently than the Piranha. The Shark unit that you see here is our proprietary piece, and this itself is a wastewater filter. So this unit allows access to thermal energy by temporarily removing solids from the wastewater stream that's pumped through this unit. We send the solids back to the sewer, and we use all of that really powerful filtered wastewater to run through a downstream heat exchanger where we move energy to or from a building. And the Shark is available right now in two sizes, with a third coming up. We anticipate it to be ready next year: the 660, the 880, and the 1212. The 6, the 8, and the 12 note the inlet and outlet size of the pipe and flanges. So, with increasing pipe diameters, we're able to see increasing maximum flow rates, which ultimately mean higher filtration and larger values when it comes to energy transfer that we're able to move to and from buildings. With this system, we can also install these units in parallel, multiple units side by side, to increase the overall flow rate, filtration, and energy transfer. And this is how we're able to scale up all the way into those district energy heating and cooling networks. So, as I mentioned, with the Shark, they are designed for those high flow rates, and they're quite variable when it comes to use. So, these are the pieces of equipment that are really used for heat source and heat sink, both heating and cooling on a large scale for your projects. Using this, we are able to capture source energy that can be used for things like domestic hot water, as well as space conditioning in terms of heating. We can also provide that energy rejection, sending energy from your building into the wastewater stream to provide cooling, or we refer to that as energy rejection. We also are able to do things like wastewater cooling when it comes to large industrial and commercial applications. So, recovering energy from that wastewater, putting it back into the system that it came from before that wastewater is discharged out to environment. And this is a real key when it comes to certain EPA regulations. And we also have the ability to pair with geofields or geoloops to provide what we call conditioning or offset. If anyone's interested in any of these, please feel free to reach out to us. We're more than happy to get into deeper discussions on any of these types of applications. Now, with the Shark, we like to refer to these as being highly effective and efficient. And overall, because as you referred to the previous slide, we are able to transfer up to megawatts of thermal energy for very, very low kilowatt energy input. There's only a few small scale motors that are used to operate the Shark system in comparison to how much heat energy we're able to move through it into or out of your building. And these units, very much like the piranhas that we reviewed, are completely sealed at the site of installation, completely odor free. They're very, very industrial, meant to keep that wastewater inside the units and out of the outside environment. And just for quick reference, this is what we refer to as the Shark system. And this is what we provide through any of our local representatives. This unit comes complete with a control panel that operates everything, the Shark filter, piping and valving with these automated valves that are used for back flushing, and the paired plate and frame heat exchanger. And this is typically designed for your project based on a number of specific items: flow rates, thermal transfer values, delta T, approach values, all that type of stuff. It's a quite a fun puzzle to put together when it comes down to it. And in terms of an installation, two quick slides just to kind of illustrate how energy is moved through the system. Both the exact same installation, we're just moving energy in two different ways. So first, what we're going to look at is energy recovery. So in this case, you're going to see the same type of wastewater holding tank or collection point. All of that sanitary wastewater is going to be used. We pump the wastewater up and through the Shark system. And first, we have here what we call a macerator. So any of the larger solids, larger diameter solids that are moved from your wastewater collection point will enter into this macerator. And this basically grinds down or chops down any of those larger solids into smaller, more manageable diameter pieces that will then enter into the Shark. The Shark will filter those solids, extract them out the bottom, and send them back to that wastewater source. And all of that filtered wastewater then passes through the heat exchanger where it moves its energy to or from your building. So in this case, we're looking at energy recovery. The energy from the wastewater is absorbed into the building loop, where that energy will then be taken into your building to be used again as source for domestic hot water, heating, hydronic heating, really any type of hot water application that you might be able to think of. And then as that wastewater temperature is lowered, the stream simply returns back to the wastewater source or right down to sanitary sewer and discharges. So we're really only interested in collecting and capturing all of that energy putting it back into the system that it came from, and ultimately getting rid of all of the sanitary sewer and wastewater down into the systems that it would normally flow to. And on the exact opposite side of the spectrum, energy rejection, the exact same process occurs through the Sharc, pumping that wastewater and solids into the system, meeting that macerator, chopping down any of those larger diameter solids into the Sharc where we filter the solids, get rid of them, and then that filtered wastewater now becomes a heat sink. So taking energy from your building space and sending it out into the heat exchanger, where that energy is then absorbed into the wastewater stream and returned back to the sanitary sewer. And in that way, we're sending in a cool or a tempered line back into your building that can be used, ongoing for cooling applications, space cooling, etc. So again, hopefully the Shark is relatively clear. Again, chat function, please feel free to pose any questions and we'll address them very quickly. But before we do that, just a couple of examples of projects. So I've got three projects here to take a look at that sort of range in size. So the first project that we're going to see is called 735, located up in North Vancouver, BC, in Canada. This is a 60 unit multifamily project. It is a stacked townhomes and condominiums. In this site, all of the sanitary wastewater discharge is collected in a small tank just at the edge of the property. We use one of our Piranha T10 units that you can see down here, capturing all of that wastewater energy, recovering it, and the Piranha puts out the domestic hot water that we use using that recovered energy directly into the hot water tanks right here that you can see beside the unit. So this is installed directly in a mechanical room. Using this, recovering that energy, we've been able to measure roughly 9,350 therms of natural gas reduced per year in comparison to their baseline natural gas boilers. So offsetting almost 100% of their domestic hot water load, resulting in almost 50 tons of CO2e per year reduced. And that's on a relatively small multifamily project. Getting into a larger project, we have the Wall Center Central Park project, again up in Vancouver, BC. This is a two-phase multifamily project developed by Wall Financial. The first phase is just over 700 multifamily units. The second phase is about half the size with 350 units. Each of the phases has their own wastewater discharge out to the city and therefore captures their own wastewater energy and putting it back into their respective phases. Phase one has one of our Shark 660 units that you can see down here, while phase two has two of our Piranha T10 units running in parallel. Both of these systems together um, result in roughly 69,000 therms of natural gas reduced in comparison to their baseline natural gas boilers. And this equates to roughly 375 tons of CO2e per year reduced across both phases. So you can see as we start to scale up, you can really quickly see a massive impact as you're seeing more and more energy recovery, electrified output, and natural gas or fossil fuel offsets. And finally, the largest project to date that has been just commissioned about 6 months ago in Denver, Colorado, the National Western Center. This is North America's largest district energy wastewater energy recovery system to date. This is a 3.8 megawatt district energy system, moving energy to and from the sanitary sewer in order to gain access to energy for heating or reject energy for cooling. So this unit sees two of our Shark 880 units, providing roughly 3,000 gallons a minute of wastewater filtration, using that as that heat source heat sink. And what they anticipate is that year over year, this project will prevent roughly 2,600 metric tons of CO2e per year from being ejected into the environment. So much larger scale, however, much larger benefits as we look into district energy. Again, sort of compounding what we're seeing in energy heating recovery, energy cooling rejection, utilizing that energy source that is literally beneath our feet and able to provide really really massive benefits not only for small scale but into these large scale multi-city blocks. This is 160 acres in fact of development that's going to be occurring over the next few years. So with that, I want to thank everyone so much for your time. I know we got started just a couple of minutes late here. But I see a couple of questions in the Q&A or in the chat function, so I'm going to try and address these really quickly. If there's anything else, please feel free to add more questions into the chat. So the first question, so this is for residential and commercial buildings. That's correct. So different applications are able to be used for different size and scale of projects. Piranhas are more on that residential side, smaller commercial side, where the Sharc is really going to come into play as we're looking at larger multifamily residential, multi-phase build-outs, et cetera, or large-scale commercial and industrial. How much is cost? How much is maintenance? These are a few questions that we'd be happy to get into offline. It depends on the size and scale of your project. A number of the questions that are posed in here: how much space is used, lifespan, all that kind of stuff. We'd be more than happy to connect offline and get into those. It really is kind of project specific based on what you need to see. And again, as we're looking at size and scale, what your application is and what it might need to do. The second question that we see is how much electric is needed. So there's a couple of different answers. With heat pumps, they have a little bit of a variable energy draw, just simply depending on what's referred to as that COP. So again, we can get into that offline. It depends on what piece of equipment and what size you're getting into as well. So we can give specific values when it comes to Piranha and Sharc, and then size and scale. So with that, I don't see any more questions coming through. Please feel free to contact us online. You can see our website here, sharcenergy.com. Also use the QR code. We'd be more than happy to interact with you and provide you some more information. Yeah, thanks everyone so much for your time and attention. I hope everyone else enjoys the rest of the Chicago Water Week conference.
Thank you, everyone.
We'll stick around for a few minutes, see if there's any additional questions that they come through. But again, thank you all so much for your attention.
Doc, we have one more question. Is National Western Center a wastewater treatment plant?
Excellent question. No, it is not. So simply what they're doing is diverting the wastewater flow through a sanitary sewer in order to access the energy, and then they send all of that wastewater back into the sewer where it continues on down the line to the major treatment center somewhere out in Denver, Colorado.